Welcome to Chapter 6 of DAT22103, focusing on cloud computing and the cloud enterprise. This chapter is titled Cloud Enterprise and will explore how businesses leverage cloud technology. We will cover key topics, including the features of cloud enterprise, examples, advantages, and the transition process. Let us understand the idea of a cloud enterprise. A cloud enterprise is a business that uses cloud-native architectures and managed services to build, run, and scale digital products efficiently. In simple words, the company designs its systems directly for the cloud so the services can grow easily and operate smoothly. To understand this better, let's look at a few key emphasis areas of a cloud enterprise. First is self-service. Engineers can quickly create resources such as servers, storage, or databases through a cloud dashboard without waiting for hardware setup. For example, a developer can launch a virtual machine in AWS within minutes. Next is automation. Many tasks run automatically, such as deploying applications or updating systems. This reduces manual work and helps systems run consistently. Another area is elasticity. Cloud resources can grow or shrink, depending on demand. For instance, during a big Shopee online sale, more servers can automatically be added to support many users. Reliability ensures that services continue running even if one server fails. Security protects systems through access control, encryption, and monitoring. Finally, observability allows engineers to monitor the system using logs, metrics, and alerts, so problems can be detected and fixed quickly. Now let's look at the types of cloud services. These services describe different ways cloud platforms provide technology to users. The first type is IaaS, Infrastructure as a Service. It provides virtual machines, storage, and networking resources on demand. In simple terms, companies rent basic computing infrastructure from the cloud. For example, a company can launch a virtual server in AWS EC2 instead of buying a physical server. Next is PaaS, Platform as a Service. It offers application runtimes, databases, and development tools to speed up coding. Developers can focus on writing applications without worrying about managing servers. A common example is Google App Engine. The third type is SaaS, Software as a Service. It delivers ready-to-use applications over the internet, such as Gmail or Salesforce. Users simply log in through a browser and start using the software. Another model is FaaS, or serverless. It executes code in response to events without managing server infrastructure. For example, AWS Lambda can run code automatically when a file is uploaded. Finally, there are managed services. These are specialized capabilities like analytics, AI or machine learning, and messaging queues that are fully operated by the cloud provider, which helps reduce operational work for companies. Many companies move to the cloud because it provides several practical advantages. One reason is faster performance. Cloud providers use optimized infrastructure that helps applications respond quickly. For example, a cloud-hosted website can load faster because the system runs on powerful data center servers. Another reason is that it is cheaper than buying hardware. Instead of purchasing expensive servers, companies can use pay-as-you-go pricing. This means they only pay for the resources they actually use. For example, a startup can run its system on a small cloud server without buying physical machines. Cloud systems also make it easy to add more users or storage. Resources can scale up or down based on demand. For instance, when many people use an online shopping platform during a big sale, the cloud can quickly add more computing power. Finally, there is no need to maintain physical servers. The cloud provider handles hardware maintenance, cooling, and power management. This allows companies to focus more on building applications instead of managing equipment. Next, let's look at key features of cloud enterprise. These features explain how modern cloud-based organizations design and run their systems. The first feature is self-service and automation. In a cloud environment, engineers can create resources such as servers or databases by themselves using a cloud dashboard or API. Many tasks can also run automatically. For example, when developers upload new code to GitHub, a cloud system can automatically deploy the updated application. The second feature is elasticity and scalability. This means cloud resources can grow or shrink depending on demand. For example, when many students log in at the same time to check exam results on a university portal, the cloud system can automatically increase computing resources to handle the traffic. The third feature is reliability and resilience. Cloud systems are designed to continue running even when problems happen. If one server fails, another server can take over so the service remains available. The fourth feature is security and governance. Cloud platforms provide tools to control user access, protect data, and monitor system activity so organizations can manage their systems safely. Now let's focus on self-service and automation, which is an important feature in cloud environments. The first idea is self-service. This means teams can create servers and databases on their own without waiting for the IT department. Using a cloud dashboard, engineers can quickly start resources whenever they need them. For example, a developer can launch a virtual machine in AWS within minutes. The next concept is infrastructure as code, or IAC. This means using code to create repeatable and consistent setups. Instead of configuring systems manually, engineers write scripts that automatically set up servers, networks, and storage in the same way every time. Another key part is the CI/CD pipeline. This stands for continuous integration and continuous deployment. It is an automated build, test, and deploy workflow. For example, when developers upload new code to a repository like GitHub, the system can automatically test the code and deploy the updated application. The result is clear: less waiting for IT and faster delivery of applications and updates. This helps companies develop and improve their digital services more efficiently. Now let's look at elasticity and scalability, another important feature of cloud systems. One key idea here is automatic resourcing. This means the cloud can add or remove resources automatically based on demand. The system monitors usage and adjusts the number of servers or computing power when needed. An example scenario is when traffic suddenly increases. For instance, when many students log in at the same time to check results on a university portal, the cloud system can scale up by adding more computing resources. Later, during quiet hours, when fewer users are online, the system can scale down and reduce the resources being used. The main benefit of this approach is pay only for what you use, which is also known as metered billing. Companies do not need to pay for extra servers that are not being used. Because of elasticity and scalability, cloud systems can handle changing workloads efficiently while helping organizations control their costs. Next, we look at reliability and resilience, which are important for keeping cloud systems running smoothly. The first concept is multi-AZ, availability zone or region deployments. This means systems are deployed across different geographical locations to ensure high availability. If one data center has a problem, another location can continue providing the service. The second concept is load balancers and auto-healing. A load balancer distributes user requests across multiple servers so that no single server becomes overloaded. At the same time, auto-healing systems can automatically detect failures and reroute traffic to healthy servers. For example, if one cloud server suddenly stops working, the system can automatically send users to another server without interrupting the service. The third concept is backup and disaster recovery. Cloud systems create backups and prepare recovery plans. These strategies are often explained using RPO and RTO, which define how much data can be lost and how quickly systems must recover after a failure. Together, these practices help cloud systems stay reliable, even when unexpected problems occur. Now let's look at security and governance, which are very important in cloud systems. The first concept is Identity and Access Management, or IAM. IAM controls who can access cloud resources and what actions they are allowed to perform. For example, in a company, a system administrator may have full access, while a normal employee can only view certain data. The second concept is encryption in transit and at rest. Encryption in transit protects data while it is moving across the internet. Encryption at rest protects data that is stored in databases or storage systems. For example, when you send files to Google Drive, the data is encrypted during transfer and while stored in the cloud. The third concept is governance. Governance includes policies, logging, and audits for compliance, such as following ISO 27001 concepts. These rules help organizations manage cloud systems responsibly and keep records of system activities. Together, security and governance help protect cloud systems, control access, and ensure organizations follow proper standards and regulations. Next is observability and cost control, which helps organizations monitor systems and manage cloud spending. The first concept is monitoring. Cloud platforms collect metrics, logs, and traces to watch system health. For example, engineers can monitor CPU usage or server response time in tools like AWS CloudWatch. The second concept is alerts. The system sends notifications when unusual behavior happens, such as high traffic, errors, or sudden spikes in resource usage. Another important idea is FinOps basics. FinOps means managing cloud costs carefully. Companies can set budgets, tag resources, and review bills regularly. The result is clear. Organizations gain full visibility and optimize spending, meaning they can see how their systems run and control how much they spend in the cloud. Next, we'll examine examples of cloud enterprise usage across different industries. Let's look at some real-world examples of how different industries use cloud computing. In the streaming industry, cloud platforms support on-demand video and music services. The cloud benefit is that the system scales for peak shows. For example, When many people watch a new movie on Netflix, the cloud automatically provides more computing resources. Next is e-commerce. Online stores use the cloud for online storefronts and payments. The cloud helps businesses handle big sales days when many customers visit the website at the same time. Another example is ride-hailing and delivery services. These platforms rely on real-time maps and matching between drivers and customers. The cloud provides low latency and global reach, allowing services like Grab or Uber to operate smoothly. In the airlines and travel industry, cloud systems support booking and check-in applications. The cloud provides high availability so passengers can access flight information or check in online at any time. Finally, in banking and fintech, cloud platforms support mobile banking applications. The cloud offers security and compliance, which are very important when handling financial data. These examples show how cloud computing supports many industries by improving performance, availability, and scalability. Let's look at some familiar names where cloud computing is used in everyday life. The first example is streaming platforms. These platforms use advanced recommendations and CDNs for instant playback. For example, when you watch a movie on Netflix or listen to music on Spotify, the cloud quickly delivers the video or music from a nearby server so the content starts playing almost immediately. The second example is online marketplaces. These platforms manage massive catalogs, persistent carts, and secure payments. For instance, websites like Shopee or Amazon store thousands of product listings and allow customers to keep items in their shopping cart while completing secure online payments. Another example is local services. Many apps provide real-time ride-hailing and food delivery logistics. Services such as Grab rely on the cloud to match drivers with customers and update maps in real time. The key takeaway here is important. Don't focus on the brands. Focus on the patterns of how they use cloud infrastructure. Different companies may use different technologies, but they follow similar cloud patterns, such as scaling resources, handling many users, and delivering services quickly through the internet. Section 6.3 discusses the various advantages of becoming a cloud enterprise. Now let's look at speed and innovation in cloud environments. One important idea is rapid deployment. Cloud platforms allow companies to launch new features faster to stay competitive. Developers can update applications quickly without waiting for new hardware. Another advantage is managed services. Cloud providers offer ready-made databases, AI, and analytics tools. Instead of building everything from scratch, companies can use these services immediately. There is also an accelerated cycle. The time from idea to prototype to product becomes much shorter. For example, a startup can build a web application, test it, and release it to users in a short time using cloud platforms. Because of this, innovation velocity becomes a key competitive advantage in the cloud, helping companies develop new solutions faster than before. Now let's look at cost and operations in cloud computing. One advantage is reduce upfront costs. Companies can minimize hardware purchases by shifting from CapEx to OpEx. Instead of buying expensive servers, they pay for cloud resources only when they use them. Another point is optimization. Organizations can right-size resources and turn off idle systems to save money. For example, a company can stop unused virtual machines at night so they do not continue paying for them. The last point is outsourcing. Cloud providers handle undifferentiated heavy lifting, such as managing data centers, cooling systems, and physical servers. Because of this, companies can focus more on building applications, while the cloud provider manages the infrastructure operations. Now let's look at reliability, security, and global reach in cloud computing. The first idea is resilience. Cloud systems are designed to handle failures. This is called design for failure, where systems can auto-recover automatically if a server stops working. For example, if one cloud server fails, another server can quickly replace it. The second point is security. Cloud platforms provide built-in security tools, compliance features, and regular audits. These tools help protect data and control access to systems. The third point is global reach. Cloud providers have data centers in many regions around the world. This allows companies to serve users across regions with low latency infrastructure. For example, a global service like Netflix can deliver videos quickly to users in different countries. The benefit is clear: consistent performance anywhere, anytime, allowing users to access services reliably from different parts of the world. Finally, we will cover Section 6.4, which focuses on transitioning to a cloud enterprise. Now let's look at a simple migration roadmap for moving systems to the cloud. The first step is assess. Organizations inventory existing apps and data, map dependencies, and analyze TCO and costs. TCO means total cost of ownership, which includes costs such as hardware, electricity, maintenance, and staff support. This helps organizations understand the real cost of running their systems. The second step is plan. Engineers design the target architecture, set up a landing zone, and configure the network and IAM. The landing zone is the starting environment prepared in the cloud before applications are deployed. It includes things like network setup, security rules, and user access control, so systems can run safely and in an organized way. The third step is pilot. Organizations start small with non-critical apps, then learn and iterate before expanding. After testing successfully, they can scale to production. For example, a university might first move a small internal portal, such as a staff attendance or internal announcement system, to the cloud. After the pilot works well, they can migrate larger systems, such as a student registration system or the university learning management system. Now let's look at the 6R migration options, which describe different strategies organizations can use when moving applications to the cloud. The first option is rehost, often called lift and shift. This means moving servers to the cloud without making changes to the application. For example, a company may move its existing website from an office server to a cloud virtual machine, such as AWS EC2. The second option is replatform. This approach optimizes the system with minor changes, such as moving the database to a managed database service in the cloud. The application still works mostly the same, but some components use cloud services. The third option is refactor. This means rewriting the application and re-architecting it to use cloud-native features. Developers may redesign the system to use microservices, containers, or serverless computing so it can scale more easily. The fourth option is repurchase, sometimes called drop and shop. In this case, the company replaces the existing system with a SaaS solution. For example, instead of running its own email server, an organization might switch to Google Workspace or Microsoft 365. The fifth option is retire. This means turning off applications that are no longer needed. During migration, companies often discover old systems that are no longer useful. The sixth option is retain. This means keeping the application as it is for now and revisiting the decision later. Some systems may remain on existing infrastructure because they are difficult or risky to migrate immediately. A useful pro tip is to pick per application, not a one-size-fits-all strategy. Different applications may require different migration approaches depending on their complexity and importance. When migrating to the cloud, establish a security baseline from day one. The first step is creating a clear IAM structure. This means defining users and roles and enforcing least privilege access so people only get the permissions they really need. Next is network segmentation. Cloud resources should be isolated using VPCs, subnets, and security groups. This helps control which systems can communicate with each other. Another important area is secrets management. Systems must securely manage API keys, passwords, and certificates so sensitive information is protected. Finally, organizations should implement backups and disaster recovery drills. This means automating backups and regularly testing recovery plans to ensure data can be restored if something goes wrong. For example, companies using AWS often store passwords in AWS Secrets Manager and automatically back up their databases to prevent data loss. Now let's look at 3 important elements in cloud transformation: people, process, and tools. First is people. Organizations need to upskill teams so they understand cloud technologies. This includes learning cloud fundamentals, earning certifications, and building a continuous learning culture. For example, engineers may take AWS or Azure training to improve their cloud skills. Second is process. Cloud adoption also requires new ways of working. Teams often use DevOps practices to develop and deploy applications faster. Some organizations apply site reliability engineering, or SRE, to keep systems stable. Many teams also follow agile methodologies to improve collaboration and adapt quickly. The third element is tools. Companies must define guardrails to manage their cloud environment. This includes resource tagging, setting budgets and cost alerts, and creating approval workflows. For example, tagging cloud resources helps organizations track which department is using certain services. Together, people, processes, and tools help organizations use cloud technology effectively and responsibly. Now let's look at a sample 90-day plan for starting cloud migration. During days 1 to 30, the focus is foundation and security. Organizations assess applications and dependencies, set up a landing zone environment, and establish a security baseline. This prepares the cloud environment before moving systems. During days 31 to 60, the focus is pilot and implementation. Teams pilot 1 or 2 applications using rehost or replatform, implement monitoring solutions, and set cost allocation tags. For example, a company might move a small internal web portal to the cloud as a test. During days 61 to 90, the focus is review and expansion. Organizations review pilot results and optimize, expand migration to the next applications, and document best practices for future projects. Finally, an exit check is important. Teams should ask, are costs visible? And is the rollback plan ready? These checks help ensure the migration is safe, controlled, and well managed. Let's look at some mini activities or checks that can help reinforce what we learned. The first activity is a quick quiz. This is a quick quiz on the 6 rupees migration strategies to check your understanding of the different migration options. The second activity is a visibility check. Here we review tagging and cost visibility in the cloud. For example, cloud resources like virtual machines can be tagged with department names, so organizations can track which team is using the resources and how much they cost. The third activity is decision time. In this task, identify one application to re-platform versus rehost. For example, a simple website might be rehosted, while a database system might be re-platformed to use a managed cloud database. These small checks help for practice for cloud decision-making in real situations. As an activity, partner up and choose an app you both use. Decide on the best migration strategy, rehost, re-platform, or refactor, and discuss the reasons why. Finally, we have the exit ticket. It contains 3 questions to review the content covered in this chapter. This is an important step to confirm your understanding of the materials. Thank you for watching this video. Remember that cloud computing allows organizations to focus on innovation instead of infrastructure.